question 1, we have to find the term independent of x in the expansion of 2x plus 1 upon 4x squared. Now we can directly guess what value of r we should use, because we know that the expansion formula is NCR a power n minus r and b power r. So either we can guess what value of r to use over here, whether we'll use 6c1, 6c2, 6c3, that will cancel out the x, or we can use this method where we write 6cr 2x to the power 6 minus r, 1 upon 4 x to the power minus 2 to the power r, and we need the power of x to be 0. So on the left hand side, the power of x will be x into 6 minus r multiplied by x to the power minus 2r is equals to x to the power 0. Now comparing the powers, we get 6 minus r minus 2r is equals to 0. So 3r is equals to 6, r is equals to 2. So using r is equals to 2, we get 6c2, 2x to the power 6 minus 2, which is 4, and 1 upon 4x squared to the power 2. 6c2 is 15, so we write 15 times 2 power 4 is 16, x to the power 4, multiplied by 1 upon 4 squared is 16, x to the power 4. So we can see that the x power 4 and x power 4 cancels out, the 16 and 16 cancels out. So the independent term is 15. In this question, we have an increasing function f where x is greater than n and n is an integer. The derivative f dash of x is x squared minus 6x plus 8. Now, as it is an increasing function, we know that the gradient of dy dx is greater than 0. Factorizing this, we get x minus 4 and x minus 2, which is greater than 0. So plotting this on a graph, the lowest value is 2 and the highest value is 4. We can see that the gradient is greater than 0 when x is less than 2 and x is greater than 4, as this is the positive half, or where y is positive. So we know that x is less than 2 and x is greater than 4. Now in the question, it is asking us for the least possible value of n. Now the least possible value of n, let's say if it was 2, so the value of 3 would give us a negative gradient. And as it is an increasing function, it means the gradient will always be positive. So the least possible value of n would be 4, as from 4 onwards, the gradient will always be positive. So the value of n will be 4. In question 3, the line y is equals to ax plus b is a tangent to the curve at the point 2 and 6. We have to find the values of the constants a, b, and c. Now from the equation of the line, gradient of the line m is equals to a. So we can write dy dx for the curve will be dy dx is equals to 6x squared minus 10x minus 3. And the point is 2 comma 6. So substituting x equals to 2, we get 6 times 2 squared minus 10 times 2 minus 3. And we know that the gradient is equals to a. So a is equals to 6 times 4, 24 minus 20 minus 3, a is equals to 1. So we can write the equation of the line is y is equals to x plus b, as the value of a is 1. Substituting the values of x and y again, 2 and 6, so we get y is equals to 6 and x equals to 2. So b will be 6 minus 2, which is b equals to 4. And finally, for the value of c, we can substitute the values 2 and 6 in the equation of the curve. So we get 6 is equals to 2 times 2 cubed minus 5 times 2 squared minus 3 times 2 plus c. Simplifying this, we get c is equals to, so this will become 2 cube 8 times 2, 16. So 6 minus 16 plus 10 plus 6. So this will become minus 10 plus 10, 0. So 6 minus 16 is, so 5 times, so this was a 2 squared, so this will be a 20, not a 10. So this will become 5 times 2 squared, 5x squared. Yeah, so this will become minus 20. So 6 is equals to 2 times 2 cube, which is 8, minus 5 times 2 squared, which is 4, minus 3 times 2, which is 6, plus c. So 6 is equals to 16 minus 20 minus 6 plus c. 6 is equals to 16 minus 20 is minus 4, minus 4 minus 6 is minus 10 plus c. So c is equals to 6 plus 10, c is equals to 16. In question 4, we have a runner who is training for long distance race, plans to run increasing distances each day for 21 days. She will run X kilometers on day 1, and on each subsequent day she will increase the distance by 10%. So as the increase is in a particular percentage, we know that it is a geometric progression. So we'll have a common ratio, which is 110 divided by 100, as if the original value was 100%, the next day it will be 110%, so the common ratio will be 1.1. On day 21, she will run 20 kilometers. So we also know that the 21st term is 20 kilometers. In part 1, we have to find the distance she must run on day 1 in order to achieve this. So we have to find the value of A. We have to give our answer in kilometers correct to one decimal place. Now the nth term is given by A r power n minus 1. As the 21st term is 20, so we'll write 20. A common ratio is r and n is 21, so 21 minus 1 will become 20. So A will be 20 divided by 1.1 to the power 20. So A is equals to 3. In part B, we have to find the total distance she runs over the 21 days. So we know that the and sum of a geometric progression is given by A into r power n minus 1 divided by r minus 1, as r is greater than 1. So the value of A is 3, r is 1.1, n will be 21 minus 1 upon 1.1 minus 1. Substituting these values in the calculator, we get the sum for the 21 days to be 192 kilometers. Question 5, we have an equation 4 tan x plus 3 cos x plus 1 upon cos x equals to 0. We have to show that sin x is equals to minus 2 upon 3. So starting with tan x, we know that tan is sin upon cos. So we can write 4 sin upon cos plus 3 cos plus 1 upon cos is equals to 0. Taking the LCM, we get, so the LCM will be cos. The denominator over here is 1, so this will also multiply by cos. So we get 4 sine plus 3 cos squared, as this will also multiply by cos, plus 1 is equals to 0. We have 4 sine plus 3 cos squared plus 1 is equals to, so cos times 0 will become 0. Now as we have to bring our equation in terms of sin x, so we can use the identity sine square plus cos square is equals to 1. So cos square will become 4 sine plus 3 into 1 minus sine squared plus 1 is equals to 0. Expanding this, we get 4 sine plus 3 minus 3 sine squared plus 1 equals 0. Rearranging the equation, we get 3 sine squared minus 4 sine minus 4 is equals to 0. Factorizing this, we get 3 sine squared minus 6 sine plus 2 sine minus 4 equals 0. Taking common 3s over here, we get s minus 2. Taking common from 2s minus 4, so we'll have 2 bracket s minus 2 equals to 0. So the final answer is sine minus 2 and 3 sine plus 2 equals to 0. Now we know that sin x cannot be greater than 1, so this will be cancelled out. So we'll be left with 3 sin x plus 2 equals to 0. So finally we have sin x is equals to minus 2 upon 3. In part 2, we have to show that 4 tan of 2x minus 20 plus 3 cos 2x minus 20 plus 1 upon cos 2x minus 20 equals to 0. So we have to find the value of x. Now we know that this whole expression is equals to sine x is equals to minus 3 upon 2. So over here we can write sine of 2x minus 20 is equals to minus 3 upon 2. Finding the basic angle, we have sine inverse of minus 3 upon 2, which is 41.8 degrees. Now we know that sine is positive in the first and the second quadrants, but as the sign is negative, we'll be taking the values in the third and the fourth quadrant. So we'll make our basic angle with the x-axis in the fourth quadrant and the third quadrant, which is 41.8. Now the angle is always measured from the positive x-axis in anti-clockwise manner. So we can write 2x minus 20 is equals to 180 plus 41.8, which will become 221.8, and 360 minus 41.8, which is 318.2. Now as our range is 0 till 180, we will not be taking any further values as it will basically go beyond 180. So we'll have 2x minus 20 is equals to, so 2x minus, simplifying this, we can get x is equals to 221.8 plus 20 divided by 2, which will become 120.9, and 318.2 plus 20 divided by 2 will become 169.1. In question 6, we have a straight line which has gradient m and passes through the point 0 and minus 2. We have to find two values of m for which the line is a tangent to the curve, and for each value we have to find the coordinates where the line touches the curve. So the first step is finding the equation of the line in terms of m. So we have y is equals to mx plus c, which is the equation of a straight line. It is passing through the point 0 and minus 2. So substituting y equals to minus 2 and mx equals to 0, we get c equals to minus 2. So the equation of the line is y is equals to mx minus 2. Now the line is a tangent to the curve. So as we have an unknown constant and it is a tangent, so we know that b squared minus 4ac, which is the discriminant, is equals to 0. Equating the two equations, we have x squared minus 2x plus 7 is equals to mx minus 2. Simplifying this, we get x squared minus 2x minus mx plus 7 plus 2 equals to 0. Now taking x common over here, we get x squared. So we'll take positive x common, we get minus 2 minus m plus 9 equals to 0. So a is equals to 1, b is equals to minus 2 minus m, and c equals to 9. So b is minus 2 minus m, so b squared is minus 2 minus m whole squared, minus 4 into 1 into 9 equals to 0. Expanding this, we get 4 plus 4m plus m squared minus 36 is equals to 0. We get m squared plus 4m minus 32 equals to 0. Factorizing this, we'll have m plus 8 and m minus 4 equals to 0. So the two values of m are m is equals to minus 8 and m is equals to positive 4. Now for each value of m, we have to find the x and the y coordinates. So over here, taking m is equals to minus 8, our equation was, when we equated the equation of the line and the curve, it was x squared plus x into minus 2 minus m plus 9. So x squared minus 2x minus mx plus 9 is equals to 0. Substituting m is equals to minus 8 over here, we get x squared minus 2x plus 8x plus 9 equals 0. X squared plus 6x plus 9. Factorizing this, we get x plus 3 and x plus 3. So the x value is minus 3. Substituting this value of x is equals to minus 3 into the equation of the curve or the line. So let's take the equation of the curve, which is x squared minus 2x plus 7. Substituting minus 3 over here, we get minus 3 whole squared minus 2 into minus 3 plus 7. So y is equals to 9 plus 6 plus 7. So the value of y is 22. So when the value of m is minus 8, the coordinates are minus 3 and 22, where the curve touches the line or the tangent. Now taking m is equals to 4, our equation will become x squared minus 2x minus 4x plus 9 equals to 0. Factorizing this, we'll get x minus 3 and x minus 3. So our value of x when m is equals to 4 will be x equals to 3. Substituting this x equals to 3 into the equation, y is equals to x squared minus 2x minus 7, we get 3 squared minus 2 into 3 plus 7. So this will become 9 minus 6, 3 plus 7, which is 10. So the coordinates where the value of m is equals to positive 4, the coordinates will be 3 and 10. Question 7, we have two functions f of x 3 upon 2x plus 1 and g of x 1 upon x plus 2. We have to find the range of f. Now as f of x is equals to 3 upon 2x plus 1 and the value of x is greater than 0, we can see that as we substitute values of x that are positive, the whole function, the value of the whole function will keep on decreasing. As the denominator will start increasing, the value of the function will start decreasing as x is greater than 0. So we know that f of x will always be, it cannot be negative, so the f of x will always be greater than 0. What we also know is that the value of the function f of x cannot be greater than 3 as we substitute values of x, the value of the whole function will start decreasing. So we can say that f of x will be greater than 0 and the maximum value will be 3, and that 3 will only be reached when the value of x reaches infinity. So we can write that f of x is less than 3 and greater than 0. For the function g of x, which is 1 upon x plus 2, we know that g of x, again over here, as x is greater than 0 for g of x as well, as we start increasing the value of x, the whole function, this whole function will basically approach 0. Now, also considering the fact that if we take a very small value of x, let's say 0.00001, this value, this function will start approaching infinity. So the minimum value that g of x can take would be 2, as let's say if this value, if the value of x was max, or we can say infinite, this function 1 upon x will be this expression 1 upon x will become 0. So the minimum value of g of x will be 2. And as if we can also take very small values of x, which will make the function infinite. So we can say that g of x will be greater than 2. Now in part B, we have to find an expression for f g of x, giving our answer in the form ax upon bx plus c. So f of x is 3 upon 2x plus 1, and g of x is 1 upon x plus 2. So for f g of x, in place of x in the function f, we'll substitute the whole function g. So we can write it as 2 into 1 upon x plus 2 plus 1. Simplifying this, we'll get 3 upon 2 upon x plus 4 plus 1, which is equals to 3 upon 2 upon x plus 5. Now taking LCM in the denominator, we'll have 3 upon 2 plus 5x upon x. So this can be rearranged and written as 3x upon 2 plus 5x. In the next part, we have to find an expression for fg inverse. So we already have the function fg of x, which is 3x upon 2 plus 5x. So for finding the inverse, first we write y in place of the function. In the next step, we exchange the values of x and y. So this will become x equals to 3y upon 2 plus 5y. Finally, for finding the inverse, we'll make y our subject. So cross multiplying, first we get 2x plus 5xy is equals to 3y. Bringing y on one side, we'll have 5xy minus 3y is equals to minus 2x. Taking y common, we get y bracket 5x minus 3 is equals to minus 2x. Finally, our answer for fg inverse of x will be minus 2x upon 5x minus 3. This can also be rearranged and written as positive 2x upon 3 minus 5x. In question number 4, we have a sector of a circle with center O, tangents AB and CD meet the circle at B. We have to find the length of OA correct to 4 significant figures. So we know that the arc length of a sector is given by the formula S equals to R theta. The arc length is S, and OA is the radius, which is R, into theta, which is 3 upon 8 pi. Cross multiplying, we get R is equals to 8 times 6, 48 upon 3 pi. Putting these values into the calculator, we get R is equals to 5.093. In part 2, we have to find the perimeter of the shaded region. So the perimeter of the shaded region consists of the arc AC, the length BC, and the length AB. Now, if we divide this figure into two equal parts, this angle will become 3 upon 16 pi. We know that the length of OC and OA is 5.093. So using basic trigonometry, we can say that for the length of BC, we'll have tan of 3 upon 16 pi is equals to opposite, which is BC, upon adjacent, which is 5.093. Cross multiplying, we'll get BC is equals to 3.4030 centimeters. And as CB is equals to AB, so the perimeter will become the arc length 6 plus 3.4030 plus 3.4030. So the final answer will be 12.8 centimeters. In part 3, we have to find the area of the shaded region. So first, to find the area of the shaded region, we can find the area of the triangle BOC. We know that this length is 3.4030. We can multiply the area of the triangle by 2 and then subtract the area of the sector. This will give us the area of the shaded region. So first, finding the area of the triangle BOC, we get half times 5.093 times 3.4030. The area of the sector would be half r square theta. So we know that the radius is 5.093 times theta, which is 3 upon 16 pi. Or we can just take the total area, we can take the total angle for the whole sector, which is 3 upon 8 pi. To find the perimeter, to find the area of the shaded region, we'll multiply the area of the triangle BOC by 2 minus the area of the sector. So multiplying the area of BOC by 2 will get 17.331 and the area of the sector would be 15.279. So putting this value into the calculator, we'll get 15.279 centimeters squared. So the area of the shaded region would be 2.05 centimeters squared. In question 9, we have a curve for which the dy dx is given and it passes through the point 2, 3. We have to find the equation of the curve. To find the equation of the curve, we will integrate the derivative. So integrating dy dx, we get y is equals to, so we increase the power by 1, we get 5x minus 1 to the power 1 upon 2 plus 1 is 3 upon 2. We divide by the new power 3 upon 2 and multiplied by the derivative of the function. So the derivative of 5x minus 1 is 5 minus the derivative of 2 is 2x plus c. Now to find the value of c, we'll substitute the coordinates 2, 3. So substituting y equals to 3 and x equals to 2, we get minus 2 times 2 plus c. So 5 times 2 is 10, 10 minus 1 is 9. So 9 to the power 3 upon 2 will become 27, as the square root of 9 is 3 and 3 cube is 27 minus 4 plus c. So c is equals to 13 minus 54 over 5 plus 4. C is equals to 17 upon 5. So the equation of the curve would be y is equals to 2 upon 15 bracket 5x minus 1 to the power 3 upon 2 minus 2x plus 17 upon 5. Now in part 2, we have to find the double derivative. So dy dx is equals to 5x minus 1 to the power half minus 2. Differentiating this, we get half times 5x minus 1. We decrease the power by 1, so this will become minus half. And we multiply by the derivative of the function 5x minus 1, which is 5. The 2 will become a 0. So the final answer would be 5 upon 2. And we can bring this 5x minus 1 to the power minus 1 upon 2 in the denominator. So this will become square root of 5x minus 1. In part 3, we have to find the coordinates of the stationary point and we have to determine the nature of the stationary point. So for the stationary point, we know that the dy dx is equals to 0. So we'll put 5x minus 1 to the power 1 upon 2 minus 2 is equals to 0. We'll take the 2 on the other side. So this will become 5x to the power 1 upon 2 is equals to 2. Now to get rid of the power 1 upon 2, we whole square both the sides. So we get 5x minus 1 is equals to 4. 5x is equals to 5. So x equals to 1. Now substituting the value x equals to 1 into the equation to find the y coordinate, we get 2 upon 5 to the power 5x minus 1. So this will become 5 minus 1 to the power 3 upon 2 minus 2 plus 17 upon 5. Substituting this in the calculator, we get y is equals to 57 upon 15. Now to find the nature of the stationary point, we'll substitute this value of x equals to 1 into the double derivative that we found in the last part. So the value of the double derivative would be 5 over 2 square root of 5 minus 1. As this will give us a positive value, and if the double derivative is greater than 0, we know that this is a minimum point. In question 11, we have a diagram which shows the shaded region bounded by the y-axis, the line y equals to 1, and the curve y is equals to x squared plus 4x plus 3. We have to express the equation in the form y is equals to x plus a whole square plus b. So to convert it into the form x plus a whole square, we can first expand the form, which will become x squared plus 2ax plus a squared plus b, and we can compare it with the original equation, which is x squared plus 4x. Now comparing the coefficients of x, on the left hand side we have 2a and on the right hand side we have 4. So the value of a would be 4 upon 2, which is 2. The constant term on the left hand side is a squared plus b, and the constant term on the right hand side is 3. As the value of a is 2, so 2 squared would become a 4. So b is equals to minus 1. So y is equals to x plus 2 whole squared minus 1. Hence for x is greater than or equals to minus 2, we have to express in terms of y. So to express x in terms of y, first we'll take the 1 on the other side. So this will become y plus 1 is equals to x plus 2 whole squared. Taking square root on both the sides, we have square root of y plus 1 is equals to x plus 2. So x is equals to y plus 1 minus 2. Now in part 2, we have to find the volume obtained when the region is rotated through 360 about the y-axis. Now, what we should know is that if it is rotated about the y-axis, our equation will be in terms of y, which we have already done in the previous part. We know to find the volume, we multiply pi by the integral of the square of the function. So we'll integrate the square function x. So the square function x is square root of y plus 1 minus 2. And the limits will be, it is given in the question, the y limits are 3 and 0. So the limits are 3 and 0. So the y limits are not 3 and 0, they are 3 and minus 1. So the limit will become minus 1. Now integrating y plus 1 square root minus 2 whole square. So first we have to square the whole function. Squaring the whole function, we get, so we can use the formula a squared plus minus 2ab plus b squared. So y plus 1 whole squared would become y plus 1 minus 2 times 2 into y plus 1 minus 4. Simplifying this, we get y plus 1 minus, and this is the square root of y plus 1. So this will be square root of y plus 1. We'll get 4 into square root of y plus 1 minus, and this is a plus 4. Now integrating each term individually, we get y squared upon 2 plus integral of 1 would become y minus 4 times. So this is y plus 1 to the power 1 upon 2. Increasing the power by 1, we will get 3 upon 2, and then we'll divide by the new power, which is 3 upon 2. The derivative of y plus 1 is 1, so it will remain as it is. And the integral of 4 would become 4y. Now substituting our limits, which are 3 and minus 1. So first we'll substitute 3 into the equation. We get 9 upon 2 plus 3 minus 4 times 3 plus 1 to the power 3 upon 2 divided by 3 upon 2 plus 4 times 3 will become 12. And then we'll subtract it from the lower limit, which is minus 1. So this will become minus 1 whole squared is 1 upon 2 minus 1 minus 4 times. So minus 1 plus 1 will become a 0. So this whole function becomes 0, and then plus 4 into minus 1. Simplify, subtracting these two values, we get 8 upon 3, and we add the pi to the final answer. So the final volume obtained is 8 pi upon 3.